So yeah, quick recap from yesterday. We finished up unit 1.2, which is where we learned how to find. We learned how to find the equation of a line or a table of values or from a graph. So we were able to look at the, we were able to find the slope of something. We were able to find that y-intercept. That y-intercept is when you have a line, whenever that crosses your y-intercept, whenever it crosses your y-axis, that's your y-intercept. So right here, in this case, it'd be 1, 2, 3, 4, 5, 6. So the point of this is 0 and 6. Your y-intercept would be +6. Then we scroll on down. And so then we moved on into scatter plots. Now, a scatter plot is a graph that looks like this. It's a graph of a whole bunch of plots, and you need to look at it and you're trying to figure out what does that actually mean. So these are the types of graphs where you're going to start, where you start getting, and you will be getting more of these today, where you need to look at it. You're not given context as to what it is. It's not like there's a farmer planting seeds and this is how much it is. It's just, here's a graph, here's plots. You're trying to figure out, does this graph look like it has some type of a straight line? Yes, this is called the line of best fit. Is this graph positive? Well, it goes up as you go from left to right. So yes, it is positive. Is there a strong correlation with this graph? Yes, because a lot of these points are really, really close. Whereas in this graph, a lot of these points are really, really far away. So this will have a weak correlation. And then the other question we asked, is there any outliers? There's none in this one, but an outlier is something that doesn't really make sense. Think about if you were measuring the average height of like your high school graduating class. Like let's say you had 50 people who graduated with. One of them's an NBA player who's like 7.5 feet tall. He's an outlier. That's not something that's like in the norm. It's not something that's average. So what we did yesterday to finish off was we looked at a couple of scatter plots and we tried to figure out similarities between them and differences. And then we found the equation from scatter plots. And so so does anyone want to remind me, how do I find my y-intercept, this plus b again? How do I find that? The y-intercept, yeah. This is why we do the review, yeah. So well, we use numbers. Yeah, we use information from a graph table of values. But what is a y-intercept? So y-intercept is when I know I just kind of slipped out. So a y-intercept is when, so it's whenever you have a line that crosses this y-axis here. When it crosses this axis, let's say it crosses right here, that's your y-intercept. In this case, your y-intercept would be 6. If it crossed right here, if you had a line going like this, it crosses at 3. If you have a line that goes, if you have this exact line we already have here, the y-intercept is 0. It's whenever it crosses this y-axis. That's what a y-intercept is. And so to figure out a y-intercept from a graph, if I look here, when does the line I've drawn cross the y-axis? At what point does it do that? So this is where it crosses the y. Oh, well, that's the slope, which we'll get to, but I'm talking about the y-intercept right now. So this line crosses the axis right here. Oh, this blue dot, this is where it crosses. It'd be 0, wouldn't it? If it crosses right here, it starts here, but that's also where it crosses it. Yeah, so in this case, it'd be 0. Now, if I'm going to use a green line here. Let's do this one. What's the y-axis of this green line? 6, because that's where it crosses the y-axis here. Yeah, so that one would be 6. So that's how we find the y-axis. Now, how do we find the slope?
y2 y1 x1 or x2 m equals y.
So really close. Yeah, so that's exactly, so y2 minus y1 all over x2 minus x1, that will always give it to you if it's a straight line. Yeah. So that's how you could find it here. If you're dealing with a scatter plot specifically, this will not work for all graphs, but it will work for linear scatter plots, for ones that have a straight line. I can just go to my line, find a point on it. But by a point, I mean these things here. I'm looking for an intersection between the two of them. I found one right here, this red dot. It was 2 and 1. It rose 1. Remember, rise over run. It rose 1 for every 2 that it ran. So my slope here would be 1 over 2. So if my y-intercept is 0 and my slope is a half, this is my equation. Y equals 1 over 2x. And then really quickly, how do you find a line of best fit? So when you guys were drawing lines of best fits at the end of the day yesterday, how do you do that again? Yeah, you're looking for a line that's going to go between an equal number of the dots. So if I have like 10 dots up top and 10 on the bottom, I don't know how many there are here. That works. If I have, let's say, 14 dots up here on the top above my line, and 6 dots below my line, that's not a line of best fit. You're basically trying to find a line that's going to be between as many points as possible. You're trying to find a line that is going to have an equal number of points above it and an equal number of points below it. So in this specific line, you probably had a line of best fit that looked something like this. Again, imagine your line is straight. And then for question B, you probably had a line that, again, looked something like, oh gosh, not that one. That looks something like this. It's a negative line versus a positive line here. So what we're going to do today is we're going to finish up scatter plots. I know I promised you some more calculator stuff. I left them at home. So we'll do that on Monday. So we get to play around with some calculators on Monday there. Does anyone want to tell me what did we learn how to do with the calculators though earlier this week? Pretty much, yeah. So what we learned on the calculators before is we learned that we could make a table of values. What's my X, what's my Y? You could plot a bunch of points in, and it would tell you what your equation was. So we learned how to do that. So I've uploaded that video there, the directions on how to do that. But if you ever get a table of values and you don't have a graph and you're trying to figure out what the line of your equation is, you can use what we learned to do that. You just have to remember how to do it. That's the hard part.
Why do you put the X on the left side?
Ooh, so the reason we put the X on the left side is because when I write it out like that chart I just had.
The Y is always on the left side. Okay?
Oh, the Y is always on the, we want to put the Y on the right side because it just makes more sense, because when you plot, you always plot along the X first. So if I had the point 1, 2, I would go to 1 on my X, and then I would go to 2 on my Y and plot my point there. Yeah. X is you, so you want to try and do X first. Now, if you do a table of values, and we've made examples of this where we put Y first, you just have to pay really close attention to when you go and plot your graph. Okay, so let's do a little bit of a warm up here before we keep going. So question 4 on page 61. On page 61. The question 4 on page 61. Give you a couple seconds to get there.
Is it mathematics or foundation?
Oh, I do. Oh,
You need this. That would be, this would be, yeah, that would be a lot more helpful. Thank you.
so 20 seconds. We'll get started. So page 61. Update my attendance. All right.
Matthew?
Mhm.
You got other questions that I'm gonna ask you?
Yeah, you'll have the chance. Yeah. So, okay, so going straight into it here. So what we want to do is we want to draw a line of best fit. Sorry, we want to add 8 data points that make this line of best fit, this line, appropriate. Because remember, when you draw a line of best fit, you want an equal number of points on the top, an equal number of points on the bottom. So that right now there's 8 points on the top. I need to put 8 points on the bottom. And you want your line to be between the 2 points. So what do you think I could do in order to make this line of best fit work? I know I need to draw 8 points, but how do I know where to put them? You're not supposed to know this yet. What's your best guess?
Do the calculations.
We don't even need to get that complex. Let's take a look at this point here. Let's look at this one right here, the one I'm circling in red. This point right here is about 2 away from my line, right? So why don't I just go 2 down and plot a point? All of a sudden, I've balanced this out, right? That's all you're trying to do is you're just trying to balance out this line so that it fits. It has an equal number of points that are about the same distance away.
So those 3 points right there, right in the middle.
Right in the middle? These ones?
Here.
So not quite. So I'm just going to go to each one of these points here. So this one looks like it's about 1 away. I'm just going to go about 1 down and draw a point. This one was 2 away. I went 2 down. I drew a point. This one looks like it's almost 1 there. So I'm going to go a little bit less than 1, draw a point, and so on and so forth. So you guys quickly finish up your graph. What do you think that would look like? Where would I put this point? Any?
Exactly directly across diagonal where you put that right point. This is.
Well, here, I'll move my mouse down. Tell me when to stop.
Same. It's the same.
Right here. This one's about a half a square away. My new point's about a half square away. This line is a little bit over 1 square away. So I'm going to go a little bit over 1 square away and plot that. What? Yeah, that pretty much, you just kind of mirroring the points. That's a much better way of putting it. Yeah. That's a much better way of putting that. Yeah, you mirror your points. There you go. Yeah, you mirror your points. I'm engraving that one to memory.
That's. But even though when you're going to one part of the diagonal, right?
Mhm.
I thought it was supposed to be mirrored. Let's say that line is water.
Yeah,
Is that what you were asking?
pretty much. Yeah. So yeah, if you're reflecting this, like if you're making it like a mirror, yeah, you just want your lines to be equal distance away. You want your points to be equal distance away from the line. So if this point is 2 higher than the line, I want to dot that's going to be 2 lower because that balances it out. Okay. So I have a line of best fit. I have my points. How can I make an equation for it now? First off, what am I always going to use when I have an equation for a line? What's my formula for that?
The last one would be 3.0.
So what's my formula for my line? Y equals. You betcha, mx plus b. And so I only need 2 things to make my line. What do I need? I need 2 things from these 4 to actually make an equation.
Y-axis and x.
Not quite. We want our y-intercept and our slope. Which one of those 2 is my y-intercept and slope? from these four things?
Slope equals.
Is it X, M, B, Y?
Run. Distance over.
Well, that's what slope is, but which of these letter represents it?
So it's like backwards.
M. So I know slope is my M, right? So that's what I'm gonna try and figure out. So I need to figure out something to put in place of M. And then what's my Y-intercept? Is it X or is it B? B. It's gonna be B. There was a bit that you missed. So I need to try and find what my M is, what my slope is, and then what my Y-intercept is. I just fill in the blanks and I have myself my equation. So what's my Y-intercept? This is the thing we just practiced. 5. It crosses the Y-axis at 5. And so then I just need to do my slope. Now, first off, I know if I need to find slope, I can do this y2 minus y1 all over x2 minus x1. I'm not going to do that in this case because I have a scatter plot. I have a scatter plot with a straight line. And when I have those two things, how else can I get my slope? So this is something that we did yesterday on page 59.
Isn't it?
That is the slope, yeah. That is what the slope is, but we need to put numbers for what that slope is.
What do you do it backwards? You gotta take care.
Think you're looking at this one? So,
Y over X.
so I think you guys are overcomplicated. So I'm going to go up to the one. That will work, but so well, hold on, one thing at a time. So we can do that y2 minus y1 all over x2 minus x1. We can do that. But remember, if I have a scatter plot and it has a straight line, I can just look at my line, find a point, and turn that into rise over run. So that was exactly what we did up here. I found a point on my line at 2 and 1. My rise is 1. My run was 2. Boom, there's a slope right there. So if I go to my current line, if I go along this and I find a point where things intersect, what's the coordinate of this? I'm going to make that green. What's the coordinate of my green point? 2 and 6, X and Y. And now I need to turn that into a slope. So what's my slope of that? 2 and 6. So M is equal to rise over run. What's my rise? 6 over 2. Now I can simplify this whole thing into y equals 3x plus 5 because it's 6 divided by 2, right? So either one of these equations would work. But does that make sense where I got that 6 over 2 from? Again, you could solve it with this thing over here on the right. But that's making it harder than you need to. You can just go to your graph, look for a point, turn that into a rise over run. You could do this though. So what I want you to do really, really quickly here is I want you to look at this graph right here, this scatter plot right below, example 3. I want you to draw a line of best fit for each of these. So for the time spent studying and the time spent exercising, and then I want you to find an equation for one of them. So draw a line of best fit for both of them. I can give you a ruler if you need. Then find an equation for one of them. I'll give you a couple minutes. I'm gonna come check what everyone's doing in about 1 minute. And if you don't have two colors of things, what you could do is you could just do like a dashed line for one of them. That would work too. So I'll give you a few minutes, draw two lines of best. So yeah, once you've done your line of best fits, you need to then find your equation. So start with your blank equation. And what's the two things I need? The two things I need from these four things to get an equation. I need slope and I need y-intercept, which is the m and the x. So those are what I'm trying to find. The m and the b. So let's do the b. That's always the easiest first. So what's my y-intercept of my green line? 16. That's when it crosses the y-axis. Yep. And then for my slope, how do I find the slope of a scatter plot with a straight line without using that fancy equation? So you're thinking it's 12 and 10. So what I want to do is I want to follow my line until I find a point that's on it. And so 12 and 10 is really close to it. It's not quite on it though. And so it does, they would probably work. 13 and 5. Yeah, that could work actually. 13 and 5. So my rise then is 13, my run is then 5. And so Kim, with your answer, that would probably work for a final exam, just so you know. That would work. But they'll probably give you a line of best fit even. So as long as you know how to find it, that's okay. Because I doubt you're going to draw one for your final exam. So that you probably get full marks for that, just so you're aware. So I have my equation now. Y equals 13 over 5x plus 16. So now I want to do my red one. So y equals mx plus b. What's my y-intercept of my red line? 12. So it's a 12, so I'm going to put that there. And then then I need to find a point on my line. And I know it's not a very good line. So 7 and 20. That could work. That could work as long as you have a concrete point. So 7 and 20. So it rises by. So if you have the point 720, it rises by 7 or 20.
Does it rise from?
Well, so this is the point she's talking about, the one I'm circling in red. So what does it rise by?
I thought our graphs that we had.
They do, but it does start at 0 over here.
I think it's 70.
So there's this, that's this point here. Oh, sorry. 20 and 7, sorry. 20 and 7. So I can see it rises by, how much does it go up by? 7. M is equal to rise over run. So 7 over 20. I now have my formula. Y equals 7 over 20x plus 12. So again, once you have a straight line on a scatter plot, you don't need to do all those fancy equations. You can just look at it and be like, it rises by this much, it runs by this much. You turn that into a slope. Okay. So what I'm going to do is I'm going to give you 30 minutes here just to kind of get as far as you can. The key thing, though, I want you to focus on is I don't care about you drawing scatter plots. Your final exam is not going to care about you drawing scatter plots. So if you go through a question and it says, hey, please draw a scatter plot, skip it. Doesn't matter. I have full confidence that you could draw this. I want you to go to the questions where you need to analyze a scatter plot. That's the important skill. It's not being able to draw it, it's being able to look at it and draw a line of best fit and figure out the equation from it and understand, is it linear? Is it not linear? Is there a correlation? Those are the types of skills that you want to be able to display. So you could frankly start straight at page 68. I'm going to give you about a half hour, and then I'm going to be giving you kind of like a unit review type thing. Because I told you, remember, you're going to write a departmental exam. I've prepared departmental style questions for you. So you'll see exactly what they're going to want you to do in March. And if you can do it here on what I'm going to give you later, you'll be good to go. That is on page 68. Sorry, I'm not zoomed in very much. You can ignore every question that wants you to draw a scatter plot. You don't need to worry about being able to draw them. You want to be able to analyze them. So I will come check up in a minute. I just wanted to do, what did I want to do? Oh, Kim, did you end up making more coffee? Yeah. You can over your shoulder. Sort of this. Yeah. Oh yeah, don't go anywhere. Yeah. Then you're perfect. So you're right. Then you think it's direct question. Remember what that means?
So you have to add to them.
Yeah, just that. So direct means it goes through 0, 0, and then partial means it's a straight line, and maybe it goes through here. Well, does your line go through 0? Does it? Looks like it does. Oh, I see. So we don't actually care about the itself. So, because if I were to tell you, like, hey, what's this point right here, you could figure it out. So every single thing on this line, your line right now, is eventually going through the two. So that is, so it is in here and then. Go through that. Yeah. One of them straight page and it's the data. So, yeah, so correlation, yes, sorry, yeah, actually, yes. Yeah. Direction is pocket. So, do you remember, there's a few that went through the lesson that you didn't remember the linear boundary? Yeah, yeah. Sorry? So linear means flat, right? So if it's linear, it means that there's a straight line. So if you remember, so the example of a linear graph means something like this. The non-linear graph means something like. So what you want to do here is, if you look at this, if you have to draw a line, are you able to do that? Yeah, you can draw straight line back. Well, give it a shot. Try to draw a line. See how it is. So you want to try and draw a line that's fit. So you want to put a ruler in the way so that the knots are above. And it's okay. So, kind of, yeah.
Reference documents,
I'm not sure.
because of the. Like if you line these dots, like. I didn't know if they were.
Oh, it'd just be one line. Oh, I see what you're saying, yeah. It's now going to be as a weak correlation. You can leave this up here. Okay. Yeah. You got it. Yeah. That's it. Oh, okay. Okay. So what you'll want to do then, where you go, Stephen? This is something else. I'm not going to.
That you're gonna suppose the new monuments.
Oh, yeah. You guys didn't know?
But
There are lots of people on the way.
I said that.
You did?
Congrats.
So you find out? Last weekend. Congratulations. So. This is, congratulations, here's that. Congratulations.
The horror. Or.
I think everyone has a feeling, oh, probably, I would have to guess, probably a mix. Right, I mean, change. So this is just what we're going on later. So if you want to start watching the videos and look at that. Oh, yeah, I don't know. These are the exams now, questions, so that's like the level of difficulty in my exam. Except if I'm multiple choice. I didn't get multiple choice. Okay, so looking at this graph now, what we're going to have is linear and nonlinear. So yeah, and then I'm only going to that's what we have.
Oh, okay.
Yeah, and so then linear, we have something that's called a vector function. So this direct is going to go through that here. Vector goes through this guy.
Yeah.
It's a great day. This is very okay. Have a great weekend.
You too.
Sorry. Yeah, it's very, very nice voice. It does, so that means it's a. That means it's gonna be a direct. So if you look at the direct, it's through. So there's two big lines up here. What if I did? Yeah, you can't do that. All right, let's hear that, yeah. And then more or less, as we get into that, right? It is plug it in as a shift. And so you write that out. Now this next question, with strength of the correlation, that's not. So in this case, so tell me what it is. Yeah, explanation, that's it, so there, all the points are very close to. Except for. We put yes, yeah. Yeah, does that make sense? Ooh, so let's see, so. So we're gonna do, there's one over page, you got pushing. On top there. So first off, when we look at these points, as we go from left to right. What do we notice? The points. Well, I don't think going down, I think as you go left to right. So yeah, so we know that negative, we know that it has a negative direction, so is it possible we can draw a yeah, so we want to try and draw a line and see if it's possible to try to straighten line with those points. I'll make sure you set it all the way. See, 100 points above, 100 points below. Okay, it's okay if it's on fire, I understand. I think I'm a little bit high. I think we had before was good, yeah. I think a little bit higher. If you want to remember half above, half below. Oh, okay. So we're gonna start all in my hole. So you literally just go and then. Yeah. Okay, so first off, does it look like this line there? So it's clear, yeah. But then is it partial, is it direct or is it partial? Why is it partial? Ooh, so you're right about being partial. But so remember, so if it's direct, it goes through 0, 0, like the one we just did. And if it's partial, it means it's stuck. So this would be a linear partial. Linear, oh, you got it right. Yeah, and what was the next question next? What else the direction is correlation? From left to right, it goes on. Yeah, negative. So linear is partial linear line, is a negative line. So how can you make it? Yeah, they're very far from. So there is a correlation as we go from left to right. We see that the points go down, but it's not close to that. And then our last question was what are your maybe, but at the same time, it could be. So we're not sure. You could make a fair argument. Yeah. Like it is far away than the other points, but it's still kind of close. So like I can get my last conclusion. I know it's almost like a 7. So it's very weak correlation. But we do see that it's right. So you can just get to that next question because we don't need to worry about where we don't have. So I'll check out the next minutes. There was 2. How's it going? So direct linear, so you understand like what it means when it says direct. That's a part of slope, so that's a positive. So that one is what we call. Yeah, so like the example I was used like that. Class with the new there. That's like a people graph, he's the guy who's like. Yeah, it is positive and it's a very strong correlation. Very close, except for that. So that's how it's. So we. Then the question. Yeah, yes, you answered the same question. Yeah. So I'm gonna recommend trying to draw yourself on the best fit. I'll see if this is easier. Yeah, so as you go from the other it's negative. So you see there's a trend, right? That you go down. So you want to try to draw lines. Yeah, usually like that. Sometimes even. Oh, 50. So like. So maybe you could have like, you could have that. Well, I wouldn't go any further than that. If you can be on like, we're doing this constantly. That's what. That was about it. Yeah. Okay, so. So linear means radius are straight. Yes. Yes, yeah. And it's right. Partial. Equation from y is partial. So you know what the red line is. So partial line of the line. Yeah. So you try to have partial. You just you can still write it. That would be a call away. I'm saying. And then if we come to the secret. That's a good term. Yeah, you could say it's water. Line to yeah, I think you go water. I would and then yeah. Oh shoot, am I still? Zoom recorded. So what I've just handed you out is something that looks like this. For you, Lindsay, I'll show you where you can find this on the LMS in a second. So these are the types of questions you can expect to answer in March. These are exam style questions. And if you go through it, you're going to notice, well, they're not making me draw a graph. No, they're not. So these are exam style questions. They revolve around you looking at the information and analyzing it and creating equations, trying to understand what it means, look at like what type of correlations there are,
So you're using this information to come to conclusions, and you're going to notice a lot of the questions are asking why. You need to be able to put it into words. Why is this the case? So you're looking at the definition for these. Why, is it linear? It's linear because it goes through 0, 0, for example. That would be an explanation. So a lot of these have prompts to explain why this stuff is important. Because if you can explain why, you're going to remember it a lot better than just immediately looking at the definition. So make sure you read the question really carefully, because that's going to be a skill you want for the actual exam. Jasmine, just making sure you're up. Another hour, I believe. So I've handed this out. Sorry, this is not supposed to be the 23rd. Change this. This is 24th. I'm going to recommend, though, you try and finish it today and the weekend as best you can. Now, I'm not going to be giving you the answers for this until after it's due, but I will try and help you out as best I can. So this is almost this. You can use your books for this. You can use the internet. You can use anything you want for this. The whole key of this is to try and get you in the mindset of how to solve this stuff. So you get to work on this for the rest. Now, if you should finish this, first off, good job. Really nice thing to do after that would be on page 72. There is an example chapter test here that you could work on if you wanted. Because we're gonna be doing a concept check for this next week. So that's just to be going over a couple questions, seeing how well we understand it. So you should work on these sample test questions. Then you can go into this chapter test. If you can do those, you are fine and dandy. No worries whatsoever. Now, to find that on the LMS, it'd be helpful if it's. So to find it on the LMS here, Lindsay, you can head on over to Unit 1. And if you scroll on down, you should find it right there. So Unit 1 exam style questions. So that's where you can find it. You're welcome to print it off, do it on Loose Leaf. You can take a picture and upload it. Either of that's fine. You can do it on Word. Anything works. So let me know if you have any questions with that or need any help about that. But so the rest of the day is time to work on that. I recommend you do it during the weekend so that you come in ready to run on Monday in case you need more time. Any questions so far? And remember, it's not due the 23rd, it's due on the 24th, so you can change that up there.